Hi, this is Dan Groninger and Dave Jankowski here for GE Inspection Technologies, and welcome to this item in our series on the use of the Mentor UT. In this video, we're going to have a close look at some of the analysis tools that are available once you have acquired a scan. And I zoomed in a little bit tighter on the instrument so you can see in a little more detail what I'm doing with my hands, how my fingers are used to interact with the instrument itself. Again, on the left side of the screen, you see the live view of what we're doing with the instrument. On the right-hand side, you see the instrument screen in much greater detail. So we already set up using our corrosion demo scanner and acquired a scan. So I've recorded, I've scanned the plate, and I've stopped recording, okay, using the start and stop recording buttons down here. So now that I have a scan acquired, when I look at things on the screen, I'm looking at my data in many different ways. So in sort of the top center here, I have the traditional A-scan view, and whatever corner or pixel of the C-scan that I'm looking at down here in the lower left, whatever's underneath the crosshair, the blue crosshair, is the A-scan that I'm going to be seeing up here on the top. So wherever my crosshair is located on the C-scans, I'll see the sector scan or E-scan that goes with that cursor position, and the A-scan underneath that crosshair. The E-scan in the upper right corner is one electronic scan across the probe. So if I have 30 virtual probe elements running on my probe, you can think of the probe as right over top of that E-scan. I'm looking at depth along this axis. I'm looking at virtual probe along this axis. So what I'm seeing is color modulated. You'll see the colors on the E-scan are matching the amplitude shown on the A-scan. And again, whatever pixel of the C-scan is selected using the crosshairs, that's where you will find the E-scan and A-scan that correspond to those. If I wanted to look at any of those in more detail, say I wanted a close look at this A-scan, I can double tap on the A-scan with my finger. That data view expands to fill the full screen. Double tap again, it goes back to the normal. I can do that with any of the data views. You'll notice as soon as I touch one of the data views, I have menu buttons that pop up. Basic interaction with the instrument. If I touch one of those buttons, the menu appears. Touch the button again, menu closes, and the buttons disappear. For the C-scan views down here at the bottom, the view on the left is called an overview C-scan, and the type of C-scan, overview or active, is assigned when that view is placed on the panel using Mentor Create software. So the author of the application chooses the function of the different views and their assignment, their placement on the panel, and so on. So when the application author built this app, he said, I'm going to put my overview C-scan on the right, or on the left rather, I'm sorry, and that will show me the overview of the entire area that I've scanned, so the entire plate in this use. On the right-hand side, we have what we call the active C-scan. And the active C-scan is sort of a zoomed-in window into the overview. So if I take my finger, I place it down, and I drag it, and then lift up, you'll notice I placed an orange box on the overview C-scan. When the area covered by that box then appears in the active window on the right. Now if I come over to the active window and do a similar gesture and draw a box, you'll see what's happened is I've drawn a box, I've moved the crosshairs automatically to the center of the box, and I got a little pop-up window with more information about what's going on within the box. So to make that a little bit easier to view, I'm going to double tap, expand it to full screen, and I see I have some important information about what's going on in the box. I have the thinnest reading seen, the thickest reading seen, a mean, back wall reduction in dB, and a minimum thickness reduction from the nominal thickness of the plate. Okay, so in this case, I see the thickest thing in the box is 504 millimeters. I've got a hole that is just visible there that comes in a little thinner at 4.5. If I come up here and look, you'll notice my thin reading is just a little more than 4 millimeters. You can see there's a much bigger color difference between this hole and that hole as well. So if I go back to my full screen, I come in here in overview, I take a close look, and you'll notice I have a couple of black spots now on my C-scan, and that indicates to me that I've got some missing data there. Okay, so why am I missing data? Well, if I look very closely, where I have the crosshair placed in the middle of one of those black areas of the C-scan. When I look up here at my A-scan, I notice, well, shoot, my signal isn't quite breaking the gate. Now in the Mentor, you have very powerful tools for reanalyzing the data in different ways. So at this point, I can either lower the threshold of the gate slightly, or I can increase the gain. And again, I'm doing this with my recorded data. I don't have to go back and rescan the plate to do that. So if I open the menu here, open the analysis menu, the 1, 2, 3 button on the C-scan, you notice I have some controls here. Offline gain, I can add 2 dB of gain, and you notice that's just enough to raise that echo for that thin spot into the gate. And if I look carefully here, I still have one grid square, and if I look at the gate on the E-scan, I see a little notch in the gate where the green bars would be in the E-scan at the beginning and end of the gate. You'll notice it's a nice thick line right across, except for this one cycle where the echo is not quite into the gate yet. So let's give that another dB or so. Yeah, it was a little more than a dB. But now you notice I don't have any missing data anymore. On the other hand, I have picked up a lot of noise on my C-scan. So the balance of choosing just enough gain to get all of the data without picking up so much gain that I get noise is one of those pieces of art related to ultrasonic inspection as opposed to science. Something else that I can do with the C-scan views is I can select a different data source. Right now we're looking at a time of flight or depth C-scan. I'm looking at a C-scan that represents the depth of thickness measured by gate A. I have a choice of amplitude, depth from gate A, gate B, or A minus B if we wanted to do say a dual multi thickness kind of measurement. I accidentally selected amplitude for gate B. It's telling me, hey, gate B is off, dummy, don't do that. If I go back, pick amplitude in gate A. Now I'm looking at an amplitude C-scan as opposed to a thickness C-scan. So as you might expect, I tend to pick up much more information from the edges and corners of things than I do necessarily from the flats. It's easy to pick out profiles of the holes that are drilled in the plate. And you should have been provided as part of the demo kit, I believe, with CAD drawings of the plate. If not, they are readily available from here at the plant. we have CAD drawings with the depth and sizes of all these holes called out, so you can use that as a reference, and you can easily evaluate the edges and things. So if I also go to amplitude view in my active window, and let's select one of these holes. All right, now if I come in here and just draw a box around the hole and kind of pick up the edges, I can also take my crosshairs, go to one corner of the hole. I see I'm at 56.5 millimeters up and 150 over. And now I'm at 156 over, 63 up. So I can pretty well conclude that's about a 6 millimeter diameter hole, give or take. And moving my crosshairs side to side. So by looking at my physical position information in the upper corner of the window, I can use these cursors to measure diameter or size, area of the indications that I'm seeing on the screen. So I think with that, we'll wrap our discussion of some of the analysis tools on the Mentor UT. Again, this is Dave and Dan for GE Inspection Technologies, and thanks for joining us.